Welcome. I've treated the sin x using first principle. I've treated the cos x using first principle. There is a popular demand that I should treat a differentiation of tan x also on first principle. So it is not rocket science. Y is equals to tan x. So we have y is equals to tan x, and we want to differentiate tan x from first principle. The first thing is that both y and x will take their partner. So we are going to have y plus change in y is equals to tan, and x will also take its partner, which is x plus change in x. So the next thing is that we need to move this y to the other side so that only delta y, that is change in y, will be in the left hand side. So the essence of what we want to do is that we want to find the derivative of tan x with from first principle. So what we have is that change in y will be left in this side, and we move this y to the other side, which is tan x plus change in x minus y. What is our y from the beginning? Our y is tan x. So we have to replace this y by tan x that we have here. So we have change in y is equals to tan x plus change in x minus tan x from the initial function. So the next thing is that we need to expand this tan addition identity. So that means we have our change in y is equal to tan x plus change in x is like having tan a plus b, which will give us tan a plus tan b over 1 minus tan a tan b. So in this case, what we are going to have is tan x plus tan change in x over 1 minus tan x tan change in x. Remember, we still have this one, so minus tan x. We can decide to put 1 under this one. It does not change the value of tan x. So what we have is over 1. You can say over 1. So the next thing is that we have to look for the LCM of the denominators. And what is the LCM? Change in y is equals to one minus tan x tan change in x. 1 minus tan x tan change in x here, 1 times the whole of what we have up here. That means we are still going to have tan x plus tan change in x minus 1 in the whole of this will give us this. That means multiply that by this. We have tan x into 1 minus tan x tan change in x, which this one extends to that place. The next thing is that change in y is equals to tan x plus tan change in x. This minus tan x will open that bracket. So we have minus tan x minus, that is plus, minus tan x times tan x, tan change in x, give us tan square x tan change in x. So everything over 1 minus tan x tan change in x. Now, look at this. We have tan x here, we have tan x here. Plus tan x minus tan x cancel out. So we will be left with tan change in x plus tan square x tan change in x over 1 minus tan x tan change in x. We are left with change in y is equals to tan change in x plus tan square x tan change in x. Everything over 1 minus tan x tan change in x. Looking at this one, we see that there is a common terms factors at the numerators. So we have tan delta x, that is change in x, and tan change in x. So we have to factor that one out. So what we have is change in y is equals to tan change in x into 1. This one remain 1 plus tan square x. Everything over 1 minus tan x tan change in x. Now we need to introduce our change in x, because what we are working towards is finding the derivative of tan x using first principle. So for us to get our dy dx, that is differentiation of y with respect to x, we need to divide both sides by changing x. This one is into 1 minus tan x tan change in x. Then we come to this place. This one is also 1 minus tan x tan change in x. So we have the y dx is equal to limit of change in y over change in x, as change in x tends to 0, equals to the product of the limit is equals to the limit of the product. So limit of tan change in x dx and limit of 1 plus tan square x over 1 minus tan x tan change in x. So by known limit of tan change in x over change in x is equals to 1. Then 1 minus tan x tan x is also equals to 1. That means we have dy dx, our dy dx is equals to the dot 1 plus tan square x over 1. So we are left which implies that our dy dx is equal to 1 plus tan square x. So dy dx, therefore if this one is equals to 1 and this one is equals to 1, so that means we are left with this. So our dy dx is equals to 1 plus tan square x, which is equals to sec square x. So our dy dx is equals to sec square x. We have come to the end of finding the derivative of tan x using first principle, which is sec square x. Please don't forget to click the subscribe button so that anytime I upload another video, you'll be the first to get notified. It doesn't cost anything. Please just click and follow, so that you give a comment if there's any area you want me to improve on what we have done. Thank you.